Recording in progress.
Okay, so let's start. I think I have another. Can you hear me double voice?
I think everybody should mute their microphones, please.
I think that was better. Is it? Outside of this. Are we still hearing the second noise? Can you hear me well?
I hear the double sound, unfortunately.
Okay.
Echo.
It's like an echo.
I wonder why, because we didn't have this before.
I think it might only be with Florencia, though. Only since we started recording.
It's because we have two recordings, Mrs. Eva. Is it? Okay. Maybe now? Yes. No. Are you still hearing the second noise?
Yes.
Oh my goodness. What are we gonna do?
But if it's only Florencia, if you try muting, maybe it'll go away. Yep, that solved it. The muting is gone now, or the echo's gone. Eva, when you talk, everything's okay?
Okay. Okay, can you hear me all?
Yeah, no problem.
Okay, so
there's no echo with me either.
Yes. Okay, so as you could perceive, we have a little bit of a duplicate problem. So Florencia is investigating what it is and how she can remedy the situation. So from my side, a warm welcome to today's webinar within the series of emerging nuclear technologies. Today we have two speakers from CNL, the Canadian Laboratory at Chalk River, who will speak to us about Canadian leadership, high precision manipulation and digital tools for modern nuclear decommissioning and environmental remediation. We also have our moderator, Holofelo Ramzilani from South Africa, who will professionally moderate this session. I would like to extend a warm welcome to all participants. I hope you will find this webinar as interesting as I will. And I also would like to thank the two speakers for making this themselves available in their free time to give us this talk. And without further ado, well, first of all, maybe I should introduce, say a little bit about who we are and what we do. So my name is Eva Jan. I am the technical leader for Win Global. And within Win Global, we have several groups of expertise. So for example, we have Women in Nuclear Innovation, Win Innovation, where Florencia is one of the co-leaders. Myself, I'm a leader of Win for Peace, which covers the areas of nuclear non-proliferation safeguards, export control and disarmament, and Holofellow is one of my members of my group. So we had this idea to organize joint workshops and webinars like this one on emerging technologies and also how they relate not only to the nuclear field, but also to safeguards and non-proliferation. So here you see a slide of women in nuclear innovation. We have Zhao Hongcheng from China, who is the current leader. And we have two co-leaders, Florencia Renteria from Mexico and Carla Kwiatkowski from Brazil. And this group was established in 2021 to involve more women in innovation. And, a lot of things are happening in the nuclear field in terms of innovation. So just to keep abreast of the latest developments in that area. And most of our activities are actually online, like this webinar. When we have the opportunity to meet physically, we also have workshops and discussions and other types of training courses. And this group has 21 members around the globe. If you are interested in joining, please check out the WIN Global website, Women in Nuclear Global. And on the top right, you will find groups of expertise. There you will find all the groups that exist and how you can join. If we move to the next slide, this is my group, Win for Peace. I established this group 3 years ago because I think we need more women in the areas of nuclear non-proliferation, safeguards, export control, and disarmament. We also mostly organize webinars, sometimes purely online, sometimes hybrid, if possible. And my group currently has 30 members from different continents. We have two supporters. One is the United Nations Office for Disarmament Affairs, and the other one is the Vienna Center for Disarmament and Non-Proliferation. We also have all our webinars, by the way, are recorded and put up on the WIN Global YouTube channel, so you can check out the YouTube channel later in case you miss any of these webinars. Okay, Florencia, can you move to the next slide? Or are we already starting? So without further ado, let me hand over. So Florencia wanted to give us this introductory speech. So let me say some words on her behalf. Beside the warm welcome, which I have already extended to you all, Florencia is behind this idea of this webinar, and she's a former IAEA fellow in the IAESTC department for supporting nuclear power infrastructure capacity building in member states. And she's also a member of WIN Mexico and the co-leader of WIN Innovation. Without further ado, allow me to hand over to our moderator, Ms. Holofellow Razilani from South Africa. She is a member of Win for Peace, and she works at NECSA, the South Africa Nuclear Energy Corporation in Pelindaba, and she works as a nuclear material accounting officer. So, Holo, the floor is yours. Thank you. And I will mute myself.
Okay. Thank you, Eva. Thank you so much. And good morning, good afternoon, and good evening, depending on where you are joining us from. A warm welcome to today's webinar. On behalf of Women in Nuclear Innovation and Women in Nuclear for Peace, thank you for joining us to this important series focused on emerging technologies shaping the future of the nuclear field. It is encouraging to see such strong interest in how innovation can support safer and more efficient and more sustainable nuclear practices. We have 99 participants registered for this webinar. You can see that many people were interested in this. And today's session highlights Canada's practical experience in applying advanced technologies to nuclear to nuclear environmental remediation and decommissioning. These are areas that present complex technical and safety challenges, but also offer significant opportunities for innovation. So you are encouraged to actively participate during the presentation. Your mic and your audio and videos will be disabled, but if you have any questions, you can raise your hand and we will be able to give you an opportunity to ask questions, or you can use the chats and we'll be able to read them for our presenters. So today we are honored to have Daniel Brashe and Jason Paioli from the Canadian Nuclear Laboratories, and they will be giving us a presentation. So Daniela Brashe, she's a section leader in decommissioning Chalk River Laboratories, Canadian Nuclear Laboratories. She supports the safe planning and execution of activities associated with legacy nuclear facilities and stored liquid waste. She brings over 22 years of experience in the Canadian nuclear industry, grounded in reactor operations, instrumentations, and control system. Daniel began her career after completing the computerized instrumentation and control technologies program at St. Lawrence College, followed by the apprenticeship as a control maintainer, then transferred into technologist role focused in instrumentation, control, and troubleshooting. During this time, she also maintained the National Research Universal Reactor Safety System, gaining critical experience with safety-related hardware and regulatory expectations. Her operational career included operating the ZED2 research reactor, where she developed deeper knowledge of reactor behavior and experimental support activities. She later served as the facility supervisor for zero energy deuterium 2, overseeing day-to-day operations, maintenance, coordination, and safe facility performance. Danielle moved into her current leadership role in decommissioning and subsequently earned her PMP certification. Early in her career, she served as the Women in Nuclear Eastern Ontario Chair for Youth and Mentorship. Building on her outreach work, supporting young women in the trades and speaking at events and career exploration events, promoting technical and STEM careers. Danielle is known for her practical operations, focused leadership, and her commitment to mentorship, knowledge transfer, and inclusive engagement within the nuclear sector. I will also introduce Jason Paioli because they are going to present one after the other. Jason Piley section is a section leader innovation for decommissioning and environmental remediation program integration for Canadian Nuclear Laboratories, where he leads the multidisciplinary team advancing digital, robotic, and remote technologies to support complex decommissioning programs. With more than 25 years of experience across the nuclear sector, Jason has contributed to fuel handling design, specialized tooling, Canada deuterium uranium spent fuel inspection, MOX fuel fabrication, robotic deployment in high hazard environments, and field leadership roles. A graduate for Sanford Fleming College, electromechanical engineering technology, a robotics program, and a certified project management professional. Jason now oversees teams utilizing advanced hexagon, Leisure, and DIS GeoRadar 3D scanning system, robotic integration, drone operations, radiation visualization, digital twin development, and 3D design and printing. His work supports global level decommissioning innovation and knowledge sharing across the nuclear community. Over to you, Danielle.
So I've got the presentation. I will bring that up now and start sharing it.
Yes, Jay is going to start.
Okay.
Give me 1 second here. And we want to share. All right, you should see it now. Give me a thumbs up, Danielle.
Not yet.
Oh, hold on, I gotta pick it again. I have to hit the share twice. Okay. And how about now?
Yes, I can see it now, Jay.
Yes.
Perfect. All right, welcome everyone. So today we're going to talk about decommissioning and environmental remediation innovations at CNL, Canadian Nuclear Laboratories. As Hollow suggested, I'm Jason Pioli, the section leader for D&DR Innovations, and Danielle is the section leader for Stored Liquid Waste Projects. So she'll be talking about a few slides as we go through. And next slide. Okay, so just a little bit about Canadian Nuclear Laboratories. We operate, or we work at the Chalk River site, which is the primary site for CNL. The Chalk River site is undergoing transformation by decommissioning old buildings to make room for new facilities. Other sites have old legacy reactors that are still owned by CNL and responsible for decommissioning. So those sites such as NPD, which is in further up the river in Ontario, Gentilly 1, which is in Quebec, White Shell 1, which is in Manitoba, and then Douglas Point, which is on the shores of Lake Huron, also in Ontario. So who are we? So with D&ER Innovations, we are a specialized group driving advanced technology adaptation at CNL with supporting decommissioning and environmental remediation with digital twins and visualization for planning and safety. We do laser scanning, BIM modeling, and photogrammetry. we also do facility radiation mapping, and we use robotic deployments to capture data in hazardous locations. We use quadrupeds, humanoids, and UAV, which are unmanned aerial vehicles or drones. So why do we come to be? So back during COVID, we had to figure out a way to get the information for our staff, who was predominantly working from home, to be able to plan work going forward safely and effectively. So we established the team and started taking some 3D scans in the field. We tried hiring a third-party vendor to perform or to develop a digital twin, and found that it was for what they were charging and the product that they were providing, it was a lot easier to self-perform because we were doing the scans ourselves anyways, again with the COVID restrictions. So that led us to explore our own internal capabilities, and we gained that, and then we rolled out that visualization to the rest of the environmental remediation management. We established a minimum viable product. The other benefit of self-performing is that we were able to establish a on-premise server so that all of our data would be would stay with CNL and not be on the cloud, and maintain security for that reasons. And we created 6 standards around our workflow. So then going forward, we created more minimum viable products of establishing our point cloud asset management, which was a interface for the users of our data to be able to request and access the information that we were gathering. And then we rolled out improvements based on user feedback and expanded to further buildings on site. And then we also started specializing scanning in high dose and contamination areas. And to do this, we utilized robotic platforms in confined and hazardous spaces. And we also started working at radiation mapping. So putting that information onto the same point clouds that we're generating. This is just a little update or our minimum viable product consists of virtual tours built from laser scans. So we collect and post-process the data using all Leica products. We also chose their cloud-based web viewer, which worked with our on-premise server. So the next step was identifying the gaps in the workflow, which was proper information management for point cloud data. So we developed the point cloud asset management systems, or PCAM for short. This acts, as I was saying, as our front end to Cyclone Enterprise, which is the underlying software that we're using provided by Leica. So we currently have published in 34 buildings with 169 billion points, 7,500 scans, and 200 active users. Let's see, next slide. So some of our scanning hardware, as was mentioned, we predominantly use Leica products. So we use the terrestrial scanners like the RTC 360 and the BLK 360. Those are tripod-based 360 scanners using LiDAR. And then we also have some portable scanners like the BLK to go, the BLK Pulse, and then now we've also started using XGrid's L2 Pro, which is a scanner that can be held on the move. And we've also got some aerial scanners like the BLK to fly, the DJI Matrice 350, which is an enterprise drone, and then the Helios 3, which is a drone specialized for indoor scanning. It also has a rad payload on it. So our capture process and workflow. So what we end up doing is when we get a request, we go out and we capture all the terrestrial scans and with drone flights. And then after we've got all that data collected, we bring it back and we register and align it and take the noise out of the point clouds. And then we can use modeling to show visible features on point clouds, walls, doors, windows, stairs, foundations, all kinds of things. And then we can reference existing drawings for any features that might have been occluded, like pipe or electrical that's inside of walls. Now here I'll give a little demonstration of what a walkthrough of our scanned results would be. It's kind of like Google Street Maps sort of thing, but obviously this is an indoor, so we can move from these orbs and have a look and pan and scan all throughout the room. And then if we want, we can toggle on to the point cloud, which allows us to give us measuring capabilities. So we can use the measurement tool. And these are all things that all our users can use. So we can measure and plan. So then we know exactly what the distance is in that room. So we can figure out what kind of equipment may or may not fit. It also gives us an idea for waste estimation. All right, so another project that we worked on where all this data collection was utilized by the planning teams to execute an actual project was the fuel storage and purification system removal. So this is what tasks that benefit from virtual tours and walkdowns. So the dose rates were recorded in the this room were upwards of 10 rem per hour or 100 millisieverts beta gamma near contact at various locations. So using the laser scans, we were enabled the team to safely plan and safely plan the scope of work while limiting access to the area. The work itself was also carrying out using remote operated equipment to reduce exposure to staff. So the room was located in a basement and a hole was cut from the outside to access the area. And a shipping container was used as an enclosure to receive and package the waste. So now I have a little video of it. You can just show or it kind of sees the evolution of the projects. We had a 3D scan before. They were able to create the plans. We kept scanning throughout the process of the project to get updated views of all the areas. So you can see where the shipping container was installed and a hole was actually cut into the wall to gain us access to this very cluttered and hazardous room. Here's a photo of the inside. And then you see on the top left, we're using Brock excavators to actually cut the pipes and remove all the waste that's generated in there. And then you see on the bottom right, we're actually applying a fixative once everything was removed so that we can leave it in a state where it's actually safe for human entry again and not have exposure to contamination or radiation. And then again, we take another scan once the project is completed so that we have an as left condition recorded. So some situations we have to use different tools to get our scanners into different areas. And from time to time, we use quadruped robots, which is a robotic dog. So you can see we've mounted on GoPros and 3D scanners on top of the dog, and then we can lower it into a hard to reach area, which may have hazardous area, radiation or asbestos. In some cases, even temperature where you would want to send people in. So we're fortunate that we're able to enter rooms briefly. But again, when you can't, this is when we turn to robots. So this robot here is the Unitree Go 1. The Go 1 has a fairly low cost compared to other platforms, and it's light enough to lower by hand, which makes it ideal for confined spaces. So we built a rail mounting on the top of the dog to put those payloads out, and we worked with a local company to develop an actual. You can see on the top left a suit to minimize contamination of the robot. Okay, the next slide. So another thing I mentioned that we use the Helios 3 drone, which is an indoor scanning drone. So having a RAD payload that's already integrated into the system and the ability to record the dose rate in 3D, it was simple to adopt. So drones are very useful in many situations, but the dust it kicks up needs to be taken into consideration, of course. For the case of the fuel storage bays where it was used, the floor and the walls were sprayed with a fixative, which eliminated the loose contamination. We used the drones to inspect the fixative to make sure it was fully applied. You can see on the bottom left photo, there's some areas that need reapplication. So we're able to let the operators know that they need to reapply. So then we use the drone to inspect the fixative and create a dose map of the bays. And our flight plan consisted of flying inches above the floor and around the perimeter, about a half-meter intervals in elevation. And this took about 18 flights to fully map the bays. And you can see the drone picked up 1.7 millisievert, and this is dose that was not exposed to people. So that was a positive note there. And then we have another little video that I can show you. So here we have the dog. We're doing some testing ahead of time before we actually put it into the bay. Just want to make sure that everything works. And then here we are lifting it in. And this is the view from the GoPro that's also mounted onto the dog. So once down, we're able to disconnect and remotely control the dog to various locations, stop every now and again, and do a 3D scan. So the paperwork that would have been required to send a person in here and the needless dose was a lot more onerous than actually having to send the dog and generate this information here. So this is the visualization result from the scans that were taken with the dog. And here we see some remote application of fixative into the bays. This is in preparation for filling these bays up with either grout or gravel to reduce the hazard of some fixed or radiation that was coming off of the walls, and also reduces the fall hazard for future decommissioning to remove all the systems and components above the bays. And again, we're talking about using the Helios 3 drone. So we did some testing, obviously, prior to flying in any hazardous location. So here we're going into the bays to inspect to see how the fixative was applied. And at the same time, you can see in the bottom right, it's getting real-time radiation measurements so that our health physics can help plan with the work going forward. It also serves to document of the conditions of the bays for future decommissioning work when we will remove the grout or the gravel that was placed in, and then we'll know what kind of fields that we're dealing with. And then we can show the visualization of the actual radiation flights, and then turns that into a heat map to show what it's like. Here we're doing some testing of some remote tooling that we use for actually filling the bay up with gravel. Obviously, this being inside a building, it was difficult to get to. We also utilized a remote packer so that we didn't have to send anyone in while we're going, and that would maintain proper compaction so that we can run heavy equipment over top of the bays once we put final caps on. So this kind of touches onto the radiation visualization things. So radiation data is overlaid to the digital twin, giving an easy to comprehend map of the gamma radiation distribution. Typically, the data that our health physics had before was just spreadsheets with locations or handwritten drawings of where radiation readings were taken. By showing this, information in a visual heat map, it gives a lot better idea of where hotspots are on various pieces of equipment or piping. Now, Danielle, I'll let you talk about this one here.
Hey, so the main mission of my team is to deal with all of our stored liquid waste on site, mainly from our previous role on site of making isotopes. So we are currently working on some tanks that have legacy cobalt-60 waste in it. And we have tanks that are buried underground full of this liquid that's been sitting for years. And we started removing liquid from one of our tanks. And as the water levels went down, so did the shielding from the high dose sediment that settled at the bottom of the tank. And we ended up with elevated radiological fields above the tank. So I think our team measured about 850 millirem or 8.5 millisieverts at the hatch, right where the drone is about to go in. And above the tank, there is some equipment that needed to be maintained. We weren't sure what radiological fields we'd be putting people into if we did send them up to do maintenance on this equipment. So we gave Jay's team a call, and they came out and they did a drone scan above the tanks, and they were able to map out what the dose rates were at what elevations and where it was really centered. Does it show that, Jay?
Yeah, should just come up here in a second. Oh, did it pause on? There we go. Sorry about that.
So yeah, right where the drone is right now, we were measuring near contact of the 850 millirem or 8.5 millisieverts. And we weren't sure what we were going to find going up in elevation. So with Jay's team's help, we were able to come up with a plan to kind of strategically perform the maintenance to make sure we got what we were required, but we weren't putting any of our workers in high dose areas for long times and in any harm's way.
For the
That's all
next
I
slide.
got for that one. Yeah.
Okay.
So this one was fun. I like this project. This is the building that has all the valving and pumps and instrumentation and equipment associated with the Cobalt-60 tanks. Back in 2012, they found underneath some stairs that a fitting had let go and it was spraying the Cobalt-60 waste all over the walls, the floors, and it had crystallized. So the crystallized Cobalt-60 waste had high dose rates coming off of it. So the building was kind of not abandoned, but put in a safe state until we could determine what to do with it. So the majority of this building hadn't been occupied since 2012, and my team wanted to go in and start cleaning up the cobalt waste and coming up with a plan for the building to get it to a safe state and ultimately decommissioned. But because of the length of time since there's been any sort of building inspection done in this building, we utilized Jay's team to come in and they did their high def 3D scanning and their dose mapping. And we were able to do a fairly comprehensive building assessment based on their scans. And we found things like a large crack in a support beam and rotting in the flooring in one section. So we were able to look from underneath and see the condition of the flooring. So we were really reluctant to put personnel in here until we got a better assessment done. And thanks to Jay's team, we were able to do the civil assessment and come up with some mitigating activities so we could safely send personnel into the building and come up with a plan to deal with the Cobalt-60 wastes. It's right under the stairs where you see the red boxes. It's a really, really tight, awkward space. So determining a path forward on how to clean that up, Jay's technology has drastically helped us start determining this. And we were able to, based on this information, determine where we should put up a wall barrier so we could take care of cleaning up the rest of the building as one project and then the cobalt waste as another project, and we wouldn't cross-contaminate. So we are able to, and we're currently cleaning up the rest of that hallway and downzoning it to allow personnel to safely enter with a lab coat and safety boots.
All right, thanks, Danielle.
Thanks, Jay.
So some of the technology that we actually used to generate that last video was a product called RavPack that was developed by a university student that we've had for the last couple summers. She's actually returning again this summer. So RavPack stands for Radiation Analysis and Visualization Portable Assessment Kit. So her first summer, she came and created a backpack that was mounted on a dog, and then last summer she was able to modularize the package so that we can then deploy it on any robotic platform. So what it does is it actually records the radiation in 3D space, and we're able to map that along with our point cloud data that we have of any facilities that we generate. So this was, again, her first contamination mapping LIMO and RAD-ISX. So the surveys and confined spaces during decommissioning require extensive planning and pose significant risks. So we're able to develop a cost-effective solution using off-the-shelf robots and equipment approved for use. So this system measures contamination levels and accurately pinpoints their locations. So during the project's development, we received a request from one of our offsite locations, and the robot was deployed just 2 weeks after the request and within 3 months of the project concept. So we knew the robot would likely be lost after completing the task, but the cost of replacing it was far less than the expense of planning a human entry. So additionally, we had a 3-week window to complete the task, while the confined space entry plan would have taken over a month to go through the process. And here's a video of the development of the LIMO. So it was essentially it was a tank that was used, and it was just about ready for decommissioning, but they wanted to confirm that there was no contamination left in the tank. And again, being a confined space would have been quite difficult. One of the information that we didn't have up front is we thought it would be clean and dry, and it turned out to be a little bit muddy. So it posed some certain challenges when we were gathering the data. You can see in the top center some elevated fields, and in reality, those fields were just from a contaminated probe. So we were able to confirm afterwards that the fields, or there was no contamination, and they were able to proceed with demolition of that tank as planned. So it was a useful or successful project on our side. Let's see. So one of the next things we're going to be utilizing is actually a humanoid robot. So the G1 humanoid by Unitree last year was the only commercially available humanoid robot on the market. So we received one of the robots at the end of June, and our student was able to help us get it teleoperation working by mid-July. So the teleoperation is controlling the humanoid robot's body and arm positions by tracking the operator's hand and body positions using the 3D goggles. So we also collaborated with a company called Indra Robotics out of Ottawa to get a comprehensive tele-based operation control, and we intend on operating the robot by specific personnel who would normally be doing the work. So like a RAD technician will actually be able to wear the goggles and operate the hands of the humanoid. and all this keeping dose as low as reasonably achievable and still maintaining the subject matter experts experience while doing the tasks. So using teleoperation, tasks can be completed in remotely hazardous locations and confined spaces. The humanoid platform sometimes is more intuitive to control, even by people who have no experience operating robots. So by wearing VR, AR goggles allows simple body position tracking and as well as a better immersion into the environment. So the aim is to be doing field tests later on in April. Um, Another thing that we have for a project is for geolocating or measuring some of our contamination storage or waste management areas. So our goals were accurate mapping and automate some repetitive tasks and get some consistent soil readings and to minimize worker risk. So this project was driven by those four primary goals. First, we aim to achieve high accuracy, geolocating the mapping of the radiological contamination across the waste management area and pinpointing any hotspots that require further investigation. Second, we wanted to automate the repetitive survey tasks to save time and reduce the physical strain to our workers. So we would typically you would have to send a person out in PPE. Sometimes most of the time it's access only in the summer and you get some hot temperatures, and wearing additional PPE can cause things like heat stress. By utilizing the robot, we're able to minimize that. So third, we wanted to ensure reliable, repetitive soil activity calculations by maintaining a consistent detector orientation and height. And fourth, we're committed to ensuring overall site safety by minimizing worker exposure to radiological, environmental, and ergonomic hazards. So these four goals, accuracy, automation, consistency, and safety, form the foundation with this quadruped called Remediation Rex. And then again, we have another little video. So this just shows the dog, how it moves around. And again, this is all remotely, so it was developed by CNL and Ares, a company out of the United States, for the advanced robotic sensors, custom software. Facilities radiological surveys at environmental remediation sites. So we address the challenges of in-field measurements and mitigates hazards with outdoor surveys. So Remediation Rex is a prototype platform being developed by us in partnership with Ares Security, and our project leverages advanced robotic sensors and custom software to facilitate radiological surveys at environmental remediation sites. In our work, we address not only the challenges of in-field radiological measurements, but also the mitigation of hazards encountered while conducting outdoor radiological surveys. Let's see, next slide. So again, we have surveys were typically performed manually, and environmental remediation staff were required to carry heavy gamma spectrometer at a set height and walk in grid lines at a set pace. The site presented a wide range of challenges that complicate manual surveys. The terrain is often complex, featuring uneven ground, steep slopes, mixed surfaces like gravel, sand, and thick vegetation that impedes movement. In addition, there are radiological concerns such as high gamma dose rates, loose surface contamination, and airborne contamination. So controlling these hazards is difficult and the labor involved is costly. Additionally, an individual's technique may lead to inconsistencies in data collections. So these challenges can be met with a robotic solution like Remediation Rex, as it does not suffer from the same issues as a human worker. So here we have a video of so our survey methodology is based on grid scanning. So the survey is segmented into a grid of squares, typically about 1 meter each. At each square, Rex pauses momentarily to record the data, then proceeds to the next. This data uses precise GPS coordinates, counts per second, and the full gamma spectrum for that location. This systematic approach ensures that no area is overlooked and that the resulting radiological map has high spatial resolution. A live radiological heat map is also available in the mission planning manager, allowing operators to immediately visualize and assess conditions assess contamination levels across the site. Once the site has been surveyed, hot squares can be flagged in the system for a second mission, and REX will return to those locations to gather more gamma spectrum if needed. If portions of the area are in question are too complex for the prototype version, of its autonomous navigation to handle, we can also log the data while the operator manually guides the robot with the controller. And the other benefit that using the Ghost Robotics Vision 60 robot as opposed to a quadruped such as Spot by Boston Dynamics is that we're able to fully field service the robot, and its legs are all IP68 rated, so we're able to easily remove them with 4 bolts and 1 connector, and put it into an ultrasonic bath to remove any contamination that is transferred to the robot. So during the field trial, Rex acquired some light surface contamination from the sand and mud in the chemical pit that it was placed into. So we were able to successfully remove the contamination using some wipes in the ultrasonic bath, and there has been no damage or loss of function due to this process. And that wraps up our presentation today. So now we will open the floor to any questions that people might have.
Thank you, Danielle and Jason, for sharing this practical innovation journey that is taking place at Canadian Nuclear Laboratories. We really appreciate the information that you have shared with us. Today's session highlights how challenges during the pandemic led to the development of the digital twin approach, uh, evolving from early setback into a successful, widely adopted solution. This is very interesting. So the few key takeaways for me is the importance of selecting the right data capture approach, whether through rapid static scanning or drone-based method to enable efficient field work. And the other takeaway is the need to maintain a strong quality control during the data registration, ensuring that point cloud data is clean, accurate, and reliable. We really appreciate the videos that you have shared, and it was very interesting for me, and I believe that even the participants have enjoyed and they have learned a lot from this presentation. So, can you kindly forward your questions if you have any in our chat, or you can even raise your hand so that all your questions may be answered. From our chat, I don't see any question, but I will ask the question that I have, and any of you can answer the question. So, how is the CNL preparing the next generation of professionals to work with digitally enhanced tools and robotic systems?
So I think the easiest way for us to ensure that we're getting the right people to do the work is the way we're hiring students in the summers to expose them to the challenges that we face and utilizing their new knowledge that they've gained at school and different ways of thinking to come up with unique solutions that can be rapidly utilized. And we've found that has been very advantageous to us, and that helps uh, not only guide our youth into the nuclear field, but also strengthens us in the future with investing in the people, right? Because they're the ones who are going to come up with the new innovative solutions in the future. So the earlier we can gauge them, the better. We do a lot of outreach with our schools in the community, and try and start, as young as possible to get people involved.
Thank you. And my second question will be, I'm checking on the chat. We are not having any question yet.
I think Ezekiel had
My
his hand up if we want to let him speak.
Okay.
Yeah, Ezekiel has his hand right up. So Ezekiel, you can unmute yourself. You're able to say your question, please. Go ahead.
Oh, okay. Thank you. How
Yeah,
does the
hello.
CN come again?
Yeah, it's Ezekiel coming with his question.
Okay.
Colo. Please, Ezekiel, go ahead.
Yes, thank you very much. I'm so glad to join this discussion, and I think the discussion is so rich with technical info. I mean, looking at the videos that were shared and then the pictures. So I have two questions. One goes to Madame Danielle. Madame Danielle spoke about measurement of radiation fields above roof. So I want to ask, are there some factors that influence the accuracy of the radiation measurements? Are there some factors that influence the accuracy of radiation measurements? As you measure radiation above the roof using a drone. And then my second question goes to Mr. Jason. Mr. Jason, a very wonderful man, sharing the videos and the pictures. Mr. Jason spoke about the dog robots. Yes, the dog robots. So I want to ask, as they work with the dog robots, do they have any challenges with the working of the dog robots? Are there some challenges with the working of the dog robots? Thank you very much.
Okay, I can start with the answer about the motives behind needing to do the scans above the roof. There is a walkway above where that roof hatch is that has equipment that we needed to maintain. So it was mainly for personnel protection, and we were able to determine how much shielding to put on top of the roof hatch to protect the worker who had to go up above it.
Okay. As far as the challenges with using robotic dogs, yes, we've experienced quite a number of different challenges. One of them has to be the wireless communications. A lot of times we are sending in these robots into areas that have thick concrete shielding, so we have to utilize mesh wireless networks and drop nodes to maintain the communication with the operators who are outside the area. Other challenges with the dogs, depending on the size of the dog, has limitations as to what obstacles that they can climb over. In one set of a trench that we're in right now has some steps that are upwards of 2 feet to be able to go over top of. So it's at the kind of the limitation of where the dog can climb over. So we were able to purchase a different dog that was a little bit larger and able to overcome those obstacles. So basically, we have different quadrupeds that we've have in our arsenal to use for different situations. So every situation is a little bit unique, and we try to assess that and then utilize the right tool for the job, which is sometimes why we have to use a drone or track crawler, or even the humanoid. A humanoid has obviously a higher reach than any of our dogs would. So that's one of the reasons we're utilizing that. I hope that answers your question.
Yes, thank you very much. But just a follow-up. So, Mr. Jesse, how do these obstacles
Sorry, I lost you there. How do the obstacles what?
yes, I'm asking how do these obstacles affect your data?
Yeah, you're breaking up. I don't know if it's just me.
No, it's you. Maybe Ezekiel, can you type your question if you're having some problems with the network? We'll appreciate that. Or if the network has recovered, maybe you can go ahead one last time.
Yeah, hello.
Yes, please go ahead.
Yeah, so
We lost you again.
It's still working, right?
Yeah, you might have to type in the question, and then I'd be glad to answer it.
Yes,
I don't know if you
please.
can tap it in the webinar chat. Hello, you're on mute if you're talking.
He's muted. Maybe Golo,
Okay,
can you go
thank
ahead
you.
with one more question if we get like Ezekiel's questions on the chat?
Okay, I don't see any question on the chat. Maybe I can ask the last question. What future capabilities or upgrades are most prioritized for high precision manipulators in the coming years? Any of you can answer.
Sure. So I think the biggest thing for us is to try and utilize the most accurate tools that are available in the market. So we're not actually developing tools. What we do is we go out, we see what's available, and then we integrate it into to our environment to gather the data that we need. So one of the big things that we do is we go to trade shows and conferences to find out what is being developed by some of our industry partners, and then we utilize those tools in collaboration to, gather you know, the the, the most accurate and concise data that we can get, right? So right now we're getting almost sub-millimeter accuracy with some of our high-end LiDAR scans, which is very helpful for the planning teams to develop their plans for remediation and ultimately decommissioning and demolition.
Okay, thank you. I believe that everyone have learned a lot from today's presentation. And this shows that innovation is iterative and driven by learning, adaptation, and continuous improvement. Thank you so much. And thank you to all our participants. And over to you, Florentia.
Thank you very much, Golo. We still have maybe 1 or 2 minutes to fill out the 2 questions that we have in the Q&A. Maybe I'll just like to comment. We have from Sky Castles. Do you have any plans for generating collision avoidance using your point cloud data? Maybe that goes to Jason or Daniel.
So yeah, collision avoidance, I think is the question.
Do you have any plans for generating collision avoidance using your point cloud data?
Yes. So the Vision 60 robot, which is the one that's used outdoors, has its own built-in LiDAR, and it does use collision avoidance to not run into any obstacles. But one challenge that we have found is that sometimes tall grass is is treated as an obstacle, and so it's avoiding walking through the tall grass. So we have to utilize our operators to override some of those decisions. But ultimately, we are utilizing the collision avoidance that's already built into a lot of the robotic platforms that we have.
Yeah, fantastic. Maybe some challenges for programming an algorithm in computing data in the future.
Yeah.
So one last question from Ezekiel. How do the obstacles you have with the robot dog affect your data, I mean, in the measurements or in the software generating database?
So because it's taking scans along multiple paths and multiple scans and generating that many points of data, a large amount of time that our technologists spend is cleaning that data afterwards, post-processing, so they can remove things like um, if there's a broom handle or a person that might be in the scan for rooms that are occupied by people, we can actually physically remove that data and then produce a nice clean result for future planning.
Whoa, that's great and fantastic. There's a lot of room for improvement and also for developing advanced tools from the next coming generation. So
Absolutely.
definitely. So with that, as we come to the close of today's webinar, we would like to extend a sincere thank you to our distinguished speakers, to Daniel, to Jason, for sharing such valuable insights into the CNL's cutting-edge work in high precision manipulation and digital innovation. Your real-world examples highlighted how advanced tools are actively improving safety, strengthening remote operations, and transforming both decommissioning and environmental remediation practices across Canada. Our great gratitude goes also to our moderator, Golo Fellow, for guiding us today's discussion with clarity and expertise, and to all of you for joining us from around the world, for your engagement and thoughtful participation. So this session is part of our broader mission within Win Innovation and Win for Peace to highlight emerging technologies and promoting international knowledge sharing within the nuclear community. We invite you to stay connected and joining us for our upcoming events in the series. So thank you once again, and we wish you a wonderful rest of your day or evening, wherever you are joining us from. Mrs. Eva, would you like to add any closing remarks for today's session? Thank you.
From my side, I was just very impressed how fast things are developing, because when I was doing my studies of nuclear engineering and the decommissioning part, and where you had to manually measure the radiation levels along contaminated walls, etc., and how things have changed so fast, and helping to reduce the exposure to the stuff. It's really amazing. So congratulations on all the great work you're doing, Danielle and Jason. And thank you very much for sharing your experiences. A big thank you from all of us. And thank you also to all of you who have attended this webinar. I hope you have found it as interesting as myself. And last not least, a big thank you to Holofellow and to Florencia for moderating, and Florencia for organizing. Thank you, and I'm looking forward to the next one.
Thank you.
Thank you very much. Have a very good rest of your day, depending where you are. Thank you.
That was great, Jay. Thanks.
Thank you. Have a great day. Thanks so much.
Thanks.
Thank you.